So I'm going to assume that by the time you're watching this lesson, you've most likely come across some other videos on Docker and you've got an overview of how it works, at least conceptually. Now in this lesson, I'm taking a more hands-on approach, a less conceptual approach by actually running through a task manager app in order to explain the key architectural features of Docker and with a special emphasis on Docker volumes and Docker's bind mount. If you're totally new to Docker, you'll probably get along fine, but I would recommend supplementing this lesson with more of an overview kind of tutorial, maybe directly from Docker's website. This is the website docs.docker.com get started overview. There are diagrams and such to help paint a mental model of what containerization is really all about. And this won't be the focus of today's lesson though, because it would be, I would try to take a more hands-on, write some Docker commands and then learn what's actually happening, kind of approach. So this way you not only see how it should work, but you get some confidence of how it actually works, line by line. So looking at this diagram, again, you have this is on an overview page, right? You see a few key glossaries to the bottom as well, but let's take a look at this. So there's the Docker host. This is your machine. This is, just think of it like if you're running this on Linux, then this is your Linux machine, right? You may have a different distro in here. You may try to write, try to load Ubuntu in here. This could be your Mac. This could be your Windows machine. This is your physical machine, right? Your host machine. And so from now on, I'm just gonna call it host. And then when you download Docker, what you download is a utility, a command line utility. You kind of think of it like a client where you issue commands to interact with what you see in here, which is the different components within this, the host, the containers, and the images. All right. So what are images and what are containers? We're gonna take a look at that later very quickly. But what you can think of it, actually, let's just do it right now. Now, image is a read-only template with instructions for creating a Docker container. So what does this mean? This really means like it's kind of a recipe, right? Think of each one of them as kind of a standalone, isolated container, and they are created from this base images. So image is kind of the recipe, kind of like a blueprint, right? You have the blueprint and you use the blueprint to create one or more containers. And you can have many different blueprints, and each blueprint can spawn one or more containers, right? So let's take a look at what images are again. So image is read-only template with instructions for creating a Docker container. So if anything, it's really just kind of a recipe for telling Docker how to create that container. Now, what about containers? A container is a runnable instance of an image. So you create a container from an image. You can create, start, stop, move, or delete the container using the Docker API or CLI. You can connect to a container. You can connect that to more networks, one or more networks, attach storage to it, and even create a new image based on its current state. All right, so that is a little bit abstract. So forget about that. So if anything, the takeaway here is that you would create this, or you would pull from a registry. We haven't talked about that yet. But you could create, in today's lesson, we are going to create an image, and then we're going to use the image kind of like a blueprint. We're going to spawn up a container. So it's an isolated instance of a running service of whatever is defined in the image. And then what about the registry? Now, registry is where you could upload your images. You could say, well, I want to push these images so that anyone else could also use the same recipe, could also use the same sort of template to create their own containers. And so this makes deployment really, really easy, because you could create an image, and the image could interact with all kind of things. It could have Elasticsearch in it, it could have Redis in it, it could have Nginx, and it could have your Python or your JavaScript code. And when you package that up like that, think of them like as like one recipe. If you were to create a container with that recipe, you're gonna have all of those different services that we just mentioned: the Nginx, the Redis, the Elasticsearch, and so on and so forth. All right, and registry is where you store them. So if you want to think of it kind of like a GitHub for Docker, you can. So it's actually called Docker Hub, and we're gonna take a look at that later. But I'm gonna just might as well show you right now. Hub.docker.com is where we go to, and hub.docker.com, it's where this is one of the registry. It's not the only registry. There's also other registry, but this is the one that we're going to be talking about. So if you would like to follow along and you want a more active stalls learning, then what you can do is to pause the video right now and just go ahead and just download Docker. And if you don't know how to do that, there's all kind of instructions in here. You could just do a Google search on like install Docker and then your OS. So for me, it's Linux. If you're using Mac, if you're using Windows, go ahead and just type install Linux, install Docker Windows, right? You could also optionally install Docker Desktop. There is a GUI app, so that kind of let me see if I could open that up right now. So there's this app called Docker Desktop, and this is kind of how it looks like, right? And you would have the containers, you have images and stuff. Now I'm not actually going to be using any of this at all, so I'm not going to be using Docker Desktop at all. It looks like it's freezing on me, but it's okay because, okay, now it's starting, but I'm not actually going to be using Docker Desktop. So it's, if you want a GUI, a graphic interface to sort of help you manage your Docker images and your containers, essentially try to minimize writing code if you can, just point and click, then I guess you could go ahead and download that Docker Desktop. Now it's running, so I have my Docker desktop. That in here I could look at all my volumes, I could look at my images and my containers. I'm not actually going to be using this as much. Probably going to keep it around there, but if you don't have Docker Desktop, that's fine. But if you want to have it, you could definitely go ahead and do the same, right? Just download Docker Desktop as well. Another thing that is optional as well is a text editor like Visual Studio Code. So I'm also not going to be using Visual Studio Code for this lesson. I'm just going to write everything in the terminal. But if you want to, this is an optional kind of, it's a really cool IDE, and I use that in all my videos. I'm sure you could, if you look at all my other videos on this channel, go ahead and just download Visual Studio Code if you want a nice code editor, if you don't want to write everything in Vim, for example. Okay. And so throughout this process in this lesson, you see we'll create an image. From the image, we'll spawn a container. And then you see that when I stop a container and I remove a container, what you'll realize is that every time this Docker container is removed, they're creating a new container of this existing Docker image. So I'm using this image one, Ubuntu image, correct? I created one container. If I remove this, I destroy this container and I spawn another container, what you'll realize is that this new container doesn't contain any data at all from the last container. All right, so creating a new container of an existing Docker image does so without making any changes to the original container. So essentially what it means is that you lose any data anytime you destroy one container and create a new one. All right, so to avoid losing data, Docker provides volumes and bind mounts. So they're gonna volumes, you hear me talk about that a lot, and then another one is bind mounts. Mounts, right? So you hear these two terms coming up a lot. So what we're going to be doing in this lesson is we're going to go through all of the basics of Docker. We're going to try and pull an image, run an image, we're going to edit some code, and we're going to then use volumes and bind mounts. And essentially, I feel like that should cover 70% of your your Docker experience. Most of the time, you're going to be doing up to this point. And then later on, maybe in a later video, I'm going to release something called the Docker Compose. We're going to be using Compose to do something more sophisticated. So this video is really not for that. It's really more for like a beginner sort of introduction to Docker kind of a video. And it's not going to go into too much advanced topics, but it is going to carry you all the way from running Docker and then talking about these two mechanisms, the volumes and the bind mounts mechanism for persisting data in your Docker container. So if you're doing any kind of DevOps work, learning how to use Docker effectively means getting to grips with at least these two key mechanisms used for persisting data. All right, so let's start by pulling the image from Docker Hub. So I'm going to go to my Docker Hub. I have a few. I'm going to go to this one, the getting started. I'm going to click on that one. You could, if you want to follow along, again, like I said, just pause the video, make sure you have Docker installed. You don't need a Docker Hub account. You could use Docker Hub without having an account, kind of like GitHub. And I'm going to click on the public view because right now this is my I'm the owner of this sort of repository, so I actually get to see how to push a new tag. But if I click on a public view, it's going to switch to a public view, which is what you're going to see. So I'm going to give you this URL later, but here it says Docker pull command. All right, so let's start off by actually pulling the image from Docker Hub. And for this demo, I've already created one for you, and it's here, Online Phantom, getting started. So I've created this and I push it onto Docker Hub so you can follow along without all the necessary setup. You don't have to sort of learn JavaScript and learn ES6 and learn React for that. You could just go ahead and just learn Docker. All right. So let's go ahead. The first step is once you have Docker, you want to make sure that you have everything by calling Docker version. You want to make sure that you have at least, this should run if you have Docker successfully installed. If you don't have that, then time to pause the video and make sure you have that installed. All right. Now the next thing you do is you do a Docker and you do a pull, and then you just put in the URL. So in this case here, this is the Docker pull, and then this is my username, this is the repo name. There is also this Docker pull command. You could just click on that sort of this copy icon, and it would just go ahead and just do that for you. And let me just run all of that. And it's gonna say using default tag latest, and you're gonna give it probably 1 to 2 minutes while it pull this from this remote. Now while we wait, let me go back to Docker and let's take a look at this. I'm gonna search for a few keywords. I think Okay, let's go back to images, and I want to maybe explain about this while we wait for the download, for the pull to complete, right? So it says when we're actually doing this Docker pull, what are we actually pulling? Are we pulling a container? Or are we pulling an image? So you're only pulling an image, all right? You're never going to be building a container. So you look at this diagram, you see that from the registry, these are places where you could find images and you could download images, you could pull images, and then you build your container from them. So if the question is, am I actually pulling, when I say Docker pull, only Phantom getting started, am I actually pulling containers or am I actually pulling images? You're actually pulling images, right? So now, here, you don't have to always pull images. You can create your own images, and we'll see how to do that in a second. But when you pull images, you skip through a lot of the process of having to create one, which is typically done through something called a Dockerfile. That's something that we're going to edit. So what it means is that as we do this Docker pull, we're actually downloading, among other things, we're downloading a Dockerfile. All right, and the Dockerfile is kind of a syntax. It's kind of a grammatical way for you to define the necessary steps, step by step, what to do to create the image and then run it. All right, so it's kind of like a set of instructions. If you want to think of it like that, think of Dockerfile as just a set of instructions, and then the set of instruction would then tell you what layers to create, creating the layers to form an image. So an image consists of multiple layers, and each instruction there goes ahead and create a layer. And so that is why if you search for the word layer, you see that coming up a lot. Now, while we wait for this as well, I'm just gonna go ahead and I'm gonna just move to my desktop just to make sure that if I were to do anything, it would be in there. I'm gonna take a look at that. I'm gonna remove my app. Okay, so there is no app folder. The reason I removed it is because I did the same I did the same exercise before recording this tutorial, and I already created a directory with app. So what I just did there was to delete that, and when I said remove, and then this is recursively, and then F is force. So R stands for recursively. It's gonna that's how you delete a folder, and then force is like don't ask, just delete everything in there, because otherwise it's gonna ask you to confirm and say, hey, look, it's a folder. I can't delete a folder. I can only delete a file. So I'm just saying rm-rf. Okay. Now what I'm gonna do is, now that I'm in my desktop, I'm gonna go ahead and say Docker images. All right. This is gonna be a little bit like it's gonna wrap down here. So I'm gonna actually create more space, and maybe even more space like this, so you can see at least everything in one line and not wrap into two lines, and you will find all the different images. So my download has not completed yet, so I don't actually see that right now, but once this is completed, you will see a new one coming up. So this is taking a little bit of time because I'm also downloading a NVIDIA driver at the same time, so let's just wait for it. But when I run Docker images again, I want you to realize that a new repository is created, and you should confirm that by looking at the created time. It should be something like a few seconds ago, 1 minute ago. So let me just wait for that, and it's almost done. It's almost done. And also a really nice thing about Docker is that you see that some of the images have already exist. For example, this one. What is this actually? So when I create the Docker file, I started the Docker file by pulling in a OS, and that OS, that Linux distro that I choose is Alpine Linux. So if you haven't heard of Alpine Linux, that's fine, but I use Alpine Linux, and what it realizes is that it says, hey, instead of downloading Alpine Linux, you already have that. How do I have that? Because I have other images in here as well, and some of them also uses Alpine Linux. So it decided that, hey, instead of actually wasting your network resources going in to download that, it's gonna check and say, hey, Alpine Linux already exists. So Docker is great that way. You could spin up something and it would do it in the most efficient manner. It will only try to pull things when it's necessary and not do a greedy approach. So here in this case here, some of this already exists. So maybe if I'm using SQLite, it already exists. Okay, so it's not gonna do any download. And then the rest, if it needs to do a download, it's gonna go ahead and download. Right, so let's just wait for it to complete, and then I'm gonna rerun Docker images, and I'm gonna see the new repository in here. Okay, now that all the different layers are downloaded, some already exist, the rest are just doing a pull. Now it says downloaded newer image, and it gave you a it gives you a status saying that it's successful. So I'm just gonna go ahead and rerun Docker images, and let's see. Now I realize that I have one new entry called only phantom getting started. So that's cool because earlier I didn't have that. And it also tells me when is it created. So it's created 46 hours ago. What is the size of that? It's 404 megabytes. Some of them are really huge. Like I see this is 1.26 gigabyte. This is Elasticsearch. I have a video. I was using Docker for Elasticsearch a little bit some time ago, and I have a video on that as well. If you want to use Docker for Kibana for Elasticsearch, go ahead, put a link there, and you could watch that video to learn how to set up Elastic and Kibana using Docker, and it's gonna be also very beginner friendly. So same here. All right, so let me clear the screen again, just to run it again, just to show you that you have now the images. So now how do you run these images as a container? So if you look at this again, it says what? It says that the container, where's the container? Let's take a look. It says a container is a runnable instance of an image. Now the keyword here is a runnable instance of an image. So an image is just a recipe, correct? It's not really a container. It's not really doing anything. It's not a live service or anything. It's not sitting up somewhere in there serving some APIs. It's not doing anything. It's just a recipe. All right. So what we want to do is we want to set up a container. We want to create a container and we want to run this. All right. So a container is a runnable instance. Let's run that. So let's say Docker, and you do it this way. You say run, and then you put in the name. And here it says only phantom / getting started. This is the name of my recipe, of my template. So I'm going to say Docker run. Now, if I were to do that, what's going to happen? Now, what's going to happen is that, let me just run it for now, right? Let me just run that. It's going to say listening on port 3000. Now, when it's saying listening on port 3000, you will be tempted to say, oh, look, I could just go to localhost and look at 3000 and it should be running, right? Well, it turns out no, because this port 3000 is actually within the containers. If you want it to be exposed to your host machine, you need to do something like a port. So let's terminate that. And now let's say Docker PS, that's all the services. We see that nothing is running right now, okay? What we want to do, instead of Docker run, what we want to do instead is we want to actually run it, and then we want to run it in detached mode so that it could continue running while returning us the terminal, TTY, and then we want to say port. Now I can combine them to become just one. So this is the same as doing it like that. So I can say DP, and then what am I going to do? Now earlier, if I look at my run, it says that it's going to listen on 3000. So I'm going to take that 3000 and I'm going to map that to my host machine 3000. So I'm going to say 3000 to 3000. So what is it saying is that whatever is happening on 3000, right, is listening on 3000. Expose that as well to the Docker host, which is my machine, our machine, right? This is your MacBook Pro, this is your PC, your laptop, your Windows machine, this is your Linux machine. So for me, I'm using a Linux, so that's my Docker host, all right? So when I say this, the P stands for port. It says that whatever it is happening in the container, so that whatever happens on the container on port 3000, you wanna map it back to the host, so that you could go to the host machine, put in 3000, and it would show you, because of the mapping, it will show you what's happening in the 3000 port in the container. So let's run that. Okay, it says that it successfully gives you some sort of a digest. So what we can do now is we can use our browser and go to localhost 3000, hit enter, and bam, we see it. So this is kind of the first the first segment of this lesson. You want to get to this point and you want to know how to run a container, how to pull a container. So the commands are quite simple up to this point, right? We say docker pull, and then this. Where do we get this from? Now, where you get this from is just go to Docker Hub and you search for any container. If you want to use Elasticsearch, you search for Elastic, and then click on search. There is a ton of options here. 15,191. This is from the community. This is from people like you and me, right? This is like from you and me. And then there is the verified content, right? So there is all of these are like official accounts in a way. They're verified. They're trusted content by probably organizations, right? So you could search for that. If you want to use Django, you could search for Django, and there's good chance you could find some Django. Click on one of them, and then you could just do the same instructions. So if you click on one of them, it's going to give you the instruction saying that do a docker pull Django. So instead of docker pull only phantom getting started, you want to have docker pull Django, and you can see this is a Docker official image. All right, now I'm gonna go ahead and get back to this, right? And I'm gonna keep it there just to make sure this is still working, right? And if we now do a docker ps, we will see now that there is a container running. You could also do a container list, and this will also show you the same thing, kind of just a shortcut, I guess. I'm gonna have to maybe move this all the way down to the left like that, right? So Docker PS, Docker container ls, kind of the same thing here. But what it does give you is it gives you the first few digits of the hash, the digest. So there is the digest here, B270, B270. And then what does it give you? It gives you an image. It tells you that, okay, this container is now built. Remember how we talk about a container being a runnable instance of an image? So it tells you that, okay, what recipe created this container? Well, this is the recipe that created container. Give you the name for that. So the name for that is only phantom getting started. All right. And then it tells you the command, which is like when you first run up a container, it needs to have an entry point. It has the command. And so what is the command that actually kick off when you first set up a run a container, right? So it gives you that information as well. And then it gives you a created timestamp. It says this is created about a minute ago. This is not your image. This is all about your container because you do a Docker container ls, right? So this is telling you the container has been up about a minute ago. And the status, if it's down, then it will tell you that you have stopped or interrupted the process or whatever. And then it also tells you that it's mapped, that anything that is listening in the container 3000 is going to be mapped to your Docker host 3000. Give you that information as well. Finally, it gives you a nickname. So this nickname is that sometimes people don't like to type this thing out. They find it difficult to refer to. So it gives you some probably more human friendly names. So this is Vigilant Swenson, right? And what's also really cool is if we click on this, I want to show you some of this stuff. I want to maybe go ahead and add a few items, and then later on I'm going to change some of this stuff here. But now this itself, this is actually built on React and stuff like that. But you don't have to learn React because you just have to do a Docker pull and it brings in all of those things. And later on we're going to get into the IDE and we're going to take a look at what's happening in here. But for now, let's just add a few items. Let's just say record lesson, and let's go ahead and just say add item. And we're going to say, do a few more. We're going to say, do some, upload the code. And then finally push to Docker Hub. All right. So we're going to just have a few items in here. And notice that everything still works. If I could cross them off and I could delete one of them. For example, I said, well, I don't need to do this anymore. I could delete that. All right. So you could try and experiment with that. If you want to pause the video and do some experimentation, feel free to do that. But what I want to show you here is that if I were to go ahead and close this out later, and I'm going to stop this container, and I'm going to boot up another container, what you realize is that none of this stuff is going to persist. And that's kind of the main, gist I want to talk about, which is why we want to learn about volumes and how to do bind mounts. Okay, we want to learn about that. But for now, I want to show you that if okay, so there is the ID. So what if you want to look at the source code for this, right? For example, you want to source. Now, the two ways to do that. One is to just go to my GitHub, and you could just go to my GitHub. I think there is one of my latest repo. Just look for my latest repo. Don't know what the name is now because I created it late last night. But it's this one, taskbot Docker. Click on that, and you could just do a git pull, and you can pull the code. But you don't actually even have to do that. So you could do that, and it will give you all of this information. It will give you all the code, and you could edit the code and stuff. But what is probably easier, and I feel like this is something that I want to talk about since we're on the topic of Docker as well, is that if you don't care for those extra files, so if you do the git pull route, you just do a git pull, or you can do a git clone and then clone the repo up there. That will give you some extra files that we'll get into, but you can also use copy, so Docker CP. So you could say Docker CP, and that is kind of a command for copy. And then what do you want to copy? You want to copy whatever code is in here. So the Vigilant Swanson. So I want to copy that. So you take all of this and you want to say Control C and you want to paste it in here. Just gonna delete this part. And then you could say, what do you want to copy from there? So I'm gonna copy from the app directory, and then you can say, where do you want to copy that into? So this is the destination. This is the source, which is from here. And within this container, there is a directory called app, and I want to copy it to this local directory, right? So I'm gonna just go ahead and say that, and now it's done. If I list directory, now I see my app again. So I'm gonna change directory to app, and then I'm gonna clear my screen. Now, if you don't know where you get that app from, you could go ahead and try and say Docker, and you can say exec, so which is execute, and you can say -it, which is iterative mode. And you want to put a name in there, so Vigilant. So usually I don't even have to type the whole thing out. I just hit on tab and it will complete that for me. So you could say Vigilant and put Swanson. And so what this will do is it's going to say, okay, I'm going to execute a command for you. I'm going to execute in this container. And so what you can do is you can put bin shell. All right, so you may think, what about bash? But because I'm using Alpine Linux, I don't actually, Alpine Linux doesn't actually have bash, it actually has shell. So we're gonna just say shell. So we're gonna just go ahead and do that. Now we can just say ls, and you will see that within app itself, there is the Dockerfile, node modules, all of these different directories. And I see some people would try to use this method and then go ahead and do some crazy hacks to bring this, to sort of extract the container code, all of this Dockerfile, node modules, package JSON and stuff, and try to bring that into the whole system. Actually, that is really not what I recommend. What I recommend you do instead is to use the Docker copy command instead. So exit. All right, so exit is the right command to get out of that. So execute, and then you say interactive mode, and then you use shell, and then from there you do an ls. You can see all the different files. And so since we see all the different files, if I list the file here, you see that all of that has been copied. So that is kind of the beauty of what this is, right? It's saying that copy from the app directory, copy all of that, and you know what all of that is because you just see me how you just see me do it, right? I basically went in there and I just execute that into the shell, and I do an ls. I could see that. I could say print working directory, and it prints out the app. That's what is in my Alpine Linux container. All right, so again, exit, and now that I have that, if I go ahead and just refresh this page again, now all of this stuff is still going to persist because the container have never been stopped. The container is still running, and the fact that you know that you can either do docker container ls or you could do docker ps, and you see that it's still running and it's still up, right? It's still up for 9 minutes. It's created 9 minutes ago. It's still up for 9 minutes. So if I go ahead and refresh this page, nothing is going to happen. All of this is still going to be there. It's not going to give me a fresh clean state again. But so let me run that. See, all of that is still there. Let me try that again. All of that is still there. But now what's gonna happen if I go ahead and do a stop? And the way you do stop is you say docker stop. Very simple up to this point, right? And you want to pass in either the name, which is Vigilant Swanson, or you want to pass in the container ID, which is B270. I'm gonna say B270, and it's gonna confirm by printing that back out there. You don't have to type the whole thing. If you want to do the whole thing, you could type the whole docker stop and then this whole digest that. But really, you don't have to. As long as you give it enough digits to be recognizable. So if let's say there's a few containers running and they have B2, let's say the first one is B270 and the next one is B267, then it would be ambiguous. So in that case, it doesn't know which one to stop. You need to provide it more digits. But in this case here, there's only one running, and that one, the first 4 digits B270 is enough for it to recognize that this is the one that you want to stop. So now that I have stopped that, if I go ahead and refresh the page, okay, now nothing's gonna happen. All right, the site can't be reached. There is nothing being streamed over to our port 3000. All right, so what could we do? We could continue to do our docker run again. So let's try that again. Let's continue to run that, and then now I want you to notice that all of those stuff are gone. So let me run that. Okay, give me a new one, F3CE. All right, and I'm now gonna refresh the page. Okay, so you have nothing in taskbar again. There's nothing again. Right, so you notice that each time we stop the container, everything is destroyed and there is no persistent data. All right, so each time a separate container is created, the name of your container is also going to be different, and you're also going to get a different a nickname. You're also going to get a different container ID. It's just going to be a completely new random one, and all the data from all the previous container, you may be changing a lot of things. You may add some logo in here, change the color of this button. You may be doing all kind of fancy stuff. Now all of that is going to be gone. So how do you persist that? And that's kind of the main idea of what we want to talk about. Okay, so let's go ahead and do a docker ps to confirm all of the stuff that we just spoke about. So you realize that now it's no longer called Vigilant Swanson, it's actually called Goofy Black. Right, so Goofy Black is the name of this container. So now if you want to stop this, you could say a docker stop, and then you could say docker stop, pass in the name Goofy Black, or you could say F3CE. All right, now while I keep that, I'm gonna keep that right here. I'm gonna go back up to my first window in here, and what I'm gonna do is I'm gonna just go ahead and open up Vim, and I'm gonna go to my second area. So there are a few folders in my app folder in here, right? So in my, this is the where I'm at. So my home directory, and then I have the app, and what I'm gonna do is I'm gonna just try to visually explore a little bit of that. So I'm gonna open up Dockerfile just to start from there. And we see there are 6 lines of sort of instructions. Remember how we spoke about the Docker being, this So images being just a template of instructions. So these are all together 6 instructions, all right? So what we do, let's just take a look at this. What we have here is that we're saying that this is the instruction. Go ahead and go to Docker Hub and look for node alpine. So you say node 12. Actually, you should search for node, click on node, and there is the node. This is Node.js, is a JavaScript-based platform for server-side and networking applications. So what we're doing is that we're saying that use this as the base template. So sort of use this as a base, all right? And then from there, Node could run on many different platforms, and we decided that it should run on the Alpine. So this is the one that we're running. So the 12 Alpine, you can use one of the other versions if you want to, right? Doesn't really matter in here. So we said from Node, get the 12-Alpine, and then take that tag, run the following command, apk-add. That's because in Linux, when you use something like Linux, Alpine Linux, you would install a software, you would use apk-add. That's kind of for adding from the repository. You install Python 2 and G++ and make. Obviously, this is all very bad practice because today you want to use Python 3, but this is on Node 12, right? And the reason why this is because it's maybe a little bit lighter anyway. So we don't have to install as much. But later on, we can always do some migration and make it maybe up to date, all right? Then what it does is that the second line is saying that after you run this line of code, you install all the software, you install the Python 2, you install G++, and you install make. Then you go ahead and just say work directory, set the work directory to be app. And which is why everything that happened beyond line number 3, everything that happened after that is going to be in the context of app. That's the new, that's kind of think of it like a CD. You change directory into app in a way. And so everything that happens in app, everything that's happened after that, so for example copy and cmd and all of this stuff and run, all of this is going to be from this directory. This is our working directory. So we set this as a working directory, and everything that happens will be done in the context of this new directory, all right? Then what do? We say copy what? Copy from our main directory, copy everything. So let me change that back to cd to that again, and I'm going to list. So there is an app, right? So I'm going to say if I go into app, clear my screen. So you see that there are a few 1, 2, 3, 4, 5, 6. There are all these 3 folders and 3 files. So what it's saying here is that copy all of them. So this will copy all of them and put them into where? Put them into the working directory, which is under the app. All right. So now I want you to just have the mental model that in your container now you will have a directory called app, and because of this copy command, you're copying all of these files in here and put them into that container's app directory. And then what's gonna happen is, okay, let's take a look at the following line. We said run yarn install -- production. Now this will work because now that you copied everything in there, you would have package.json. Let's take a look at package.json, right? So it's gonna go down here. Let's click on run. So now we see package.json. And package.json, if you actually program any kind of, if you're a front-end developer, if you're a React developer, any kind of a front-end engineer, you will see package.json. This is very familiar to you. This is kind of how we manage dependencies. So you see that you have to install a couple of things in dev dependencies. These are dependencies that you want to install when you're doing development. So Jest, Node-RED, Prettier. And then there is also other dependencies like here. You see MySQL, SQLite, and Express. All right. So let's go back to sort of Dockerfile. When you say yarn install, it's gonna look at your package.json and go ahead and install all of that. All right. And then finally, it's also gonna, this is the CMD, stands for command. It says that when I first initialize the container, when I first boot up the container, what do you want me to do? And so here it says use node to serve into source index.js. So let's take a look at that as well. Let's go up to source and let's take a look at index.js, and this is index.js. All right, so this is a simple node app. So finally, we exposed port 3000, which is why we could do the mapping. We said map this 3000. Now I want to say that if you have done any kind of Docker development before, you could see a few ways this could be improved already. And that's cool because that's really not the main topic here. I want to keep things simple, but later on, as we go on, as we build upon this, we're gonna find ways to say, oh, this is the better ways to do this, and there's better ways to do that. And so we're gonna modify some stuff, and later on, ideally want to have a Docker compose file to do all of that. But for now, this is good enough. We don't need to worry too much about this being completely optimal. And if you wonder like, well, can you use some other kind of base image, you can absolutely use anything that has Node on it. The reason I use Alpine is because Alpine is a Linux distro that is going for sort of a no-frills, minimalism, security-oriented distro, and because it's minimalist and it's lightweight, this characteristics made it a popular choice on Docker, since the image size would then be relatively lighter compared to other base Linux image. All right. So let's go into static source. We want to go into static and take a look at JS. Now there's a couple of things in here. I want to just open up app.js, and if you go back into this, so there is the function app. If you actually write any kind of React code, you've probably seen this before. There is the react.useState, react.useEffect. Okay. Now I want to just go to line 56, the line 56. So I just I'm using Veeam, so I say 56, and then capital G is gonna move to that line. And let's say we want to actually modify some of this text here. So it currently says you have nothing. It currently says you have nothing in taskbar, right? So if I go ahead and instead of taskbar, I want to say get things done. Okay. So I'm gonna call it GTD now. Kind of like it's a very common name for to-do apps. A lot of to-do apps are called get things done, right? So getting things done. So you have nothing in GTD, add one above. Just say nothing in GTD, so add one above. So very simple line. Just say nothing in GTD, add one above. All right. Now what I'm gonna do is I'm gonna go ahead and save this file because I make some edits in here. So I only edited line number 56, and that's nothing in GTD, add one above. So we're gonna say write, and that's gonna write this file. All right. If I click on this, nothing should happen because this is still running the old container, right? We only modify the recipe, but we haven't built a new item from the recipe. So what we did was we modified these images, but the container has already been running. It has always been running. So this itself is still launched 10 minutes ago from the image that was in the earlier state 10 minutes ago. So it doesn't reflect this change, right? So what do we do here? Now, what do we do is we have to just build a new container, just build our updated version of the image. So let's go ahead and do that. We could say docker build. Actually, let's make sure I'm in the right directory. Okay, that's cool. And I'm going to say docker build. And then what? I'm going to say docker build, and I'm going to give it a tag. I'm going to say this, and I'm going to say getting started or get things done, like this, right? And then it's going to ask you, okay, where is the Docker compose file? So the Docker compose file is in my current directory, so I'm just going to put a dot. All right. So what this is going to do is it's going to look for a Docker compose file in the current directory because you say dot, and it's going to build a new image. And then once the new image has been built, it's going to give it a tag called GTD. So get things done. So let's run that, and it's going to now go ahead and do that build. And it's done. So you could see that these are all the different actions, and some of this stuff it actually use a cache, meaning it says, hey, I don't actually need to do this add stuff because nothing has changed there. So if I go ahead and show you what I mean by that, so there is the Dockerfile, right? See, it realized that, hey, I don't need to do any of this. This is all still is using the cache here because the step one from Docker, it says, well, that is not necessary, and then run APK, that is also not necessary, and then it says copy, and then finally it tries to copy is where it's actually making changes, because copy this file has been changed. So up to this point, all of this is still the same, so that's why none of that they're actually gonna be using cache. So the actual step that start off is the copy, and then it's gonna export that, and it's gonna run the yarn install production. All right. Now let's go back here and let's say docker ps, and this is getting a little bit too long, so I'm gonna go ahead and clear my screen. So do docker ps again. So I still see goofy black, and that's 30 minutes ago. So I want to go ahead and stop that. So docker stop goofy black. All right, and then I'm gonna say docker images ls without the ls actually. You see that there's a GTD now. So that's the one that we just built. This is built only 2 minutes ago. So what we want to do is we want to just clear the screen. We want to say docker run, and we want to say the GTD, right? But again, remember, we need to run it in detached mode, and then we need to map the port. We need to map the port 3000 to 3000, because otherwise we won't be seeing, we on our host machine, whatever is happening in the container, it's not going to be exposed to our host, right? It's not going to be streamed to our host. So I want to do that, and let's run that. Okay, it give you F3.1c. So if you want to stop it, this is how you do it. But let's go ahead and run it and let's see. Ideally, you want to see that things have been updated to GTD. It should say that nothing in GTD at 1 above. So let's run that, refresh that. Okay, done. So if I refresh the page, it says nothing in GTD at 1 above. Now, if you see an error while trying to run that, then what you need to do, if you try to run this Docker run and then you get an error, then most likely what's going to happen is, what happened is that you are not able to start a new container because your old container is still running. Now, it is because the old container is still using the host port 3000. So this pod is completely busy. It's being occupied by the old container, and only one process on a machine, including containers, can listen to a specific pod. So this is not really a Docker thing. It's kind of a basic networking thing. If you learn computer networking, this is the host machine's port 3000, and only one process can occupy that at one time. All right. So since the first container is already occupying the port 3000, now the second one cannot go ahead and it cannot use the same port as well. So to fix that, you just need to go ahead and remove the old container, just doing the same thing that I showed you. You can say docker stop, and in that case, my name is Goofy Black in that time, but yours, you may have a different one, so go ahead and just pass in the right one there, or you could just pass in a container ID. So in this case, if I want to stop this, I'll say F3.1c. All right. If you want to just remove that completely, you can also just do a docker remove after docker stop. So I could say docker remove, and then I could say Goofy Black. Black. Want to spell that correctly, and now it's removed. By the way, if you want to stop and remove at the same time, so let me show you what I mean by that. If I want to say docker, if I go ahead and remove this dreamy chatterlet, it's not gonna work. Why? Because I haven't stopped that yet. So if I try to run this, so I'm gonna say F3.1c, it's not gonna work. It's gonna tell me that the container is still running, it can't be removed. So you either have to do a docker stop F3.1c and then docker remove F3.1c, or you could do them in one line by adding the -f. So -f means force, so you kind of like remove it and force remove it. So if it's not stopped, stop it and then remove it. So that's also another option. All right, but so far, what have you learned? You've learned how to make edits, make some modifications, rebuild the image, and then you could try to run the container on that new image, and then you could see that the new changes have already been reflected in your container. So that is great. But there is still one problem, is that if we just go on and add another item in here, let's just say read some books, okay, and then go to the gym, read some more books. Read books while at the gym, and then read gym while at the books. Okay, so let's go ahead and add some items in there, and if I delete them and I cross this out and I delete this, now if I were to stop this and I remove this and I were to rebuild another container using that same image, the GTD image, what do you think is going to happen? Would they be persisted? Would I still see all of my sort of my state in here? Would I see all this data in there? So what do you guys think? Okay, if I were to go ahead and just remove this, right, refresh this page, nothing, and I go ahead and just do a build again. Whoops. Here, do you think you're gonna find all of that? Let's go and see it. Let's see if you're right or if you're wrong. Okay, now that we run that, so let's look at Docker run dp, and now let's run that again. Okay, let's refresh this page. Whoops, there's nothing again. So if your earlier answer was there should be nothing in here, then you're right. So Docker is in a way, it's called ephemeral. So it's that it doesn't actually store anything. Ephemeral, right? So it basically, when you destroy a container, everything goes with it. Okay, now this is the time to actually segue into Docker volumes, right? Volumes are great. Volumes is kind of it's a great mechanism for adding a data persisting layer in your Docker containers, especially for a situation where you need to persist data after shutting down your containers. You want to be able to shut down a container, but every time you boot it up again, you should still see all the same items. It shouldn't just be gone. All right. So Docker volumes are completely handled by Docker itself, and therefore they're independent of both your directory structure and your OS, the OS of your host machine. So when you use a volume, a new directory is created within Docker's storage directory on the host machine. And in a short second, I'm going to show you where that is, right? And you can also use the same technique to go and find out where that is. But what I'm trying to say here is Docker would manage everything in that special directory. So all the volumes are handled by Docker itself, and there is a special directory that Docker handle completely regardless of what OS you're using and regardless of your directory. So it won't be in this app folder, is what I'm saying. If you try and type ls and you say, hey, there's no sort of volumes folder, what is happening? Well, that's because Docker doesn't put them in there. So you could change this directory as much as you want. You could add new things, remove new things, use GitHub to sort of go back and forth on this, and it doesn't affect your Docker volume, because that special directory that is going to be managed completely within Docker itself, and you don't really even have to know where that is, but it's somewhere on your machine. So with the previous experiment, when every time we change stuff and we rerun the image, so we saw that each container starts from the image definition again. So it runs from the from node 12 alpine run apk work directory app copy ... You see all of this, right? It starts from the image definition each time it starts. Now, while containers can create, update, and delete files, those changes are lost when the container is removed. Okay, and so all changes are, in a way, let me just show you the image again. This diagram is so helpful. So in a way, when the container is removed, all the changes are isolated to that container. So all the changes in here are also going to be removed, right? With volumes, though, we can change that. So now let's talk about the first concept in there, right? So we're going to talk about volumes. Now, volumes provide you the ability to connect specific file system path of the container back to the host machine. So I could say, if I take a look at this, let me just go back up to my code, and I'm going to look at the second one. I'm going to go all the way up to maybe persistence. Actually, I'm going to go into specs, and I'm going to look at the persistence, and then there is this SQLite spec.js. I'm going to click into that. You realize that there is a few things here. So let me set this to wrap so that you can see everything. So it says here the constant location equals to either find, if it's provided through an environment variable, use that. Otherwise, it's in etc todo.db. So this is where I set up the specification. That's why it's in the spec folder. And within that, I define where the database is going to sit. And it's going to sit in a special etc, etc, and then todos, and then within it, it's going to be a todo.db. So if you see todo.db, what does it tell you? It tells you that it's a SQLite. Okay, so what do we know? We know that the todo app stores its data in a SQLite database in here. And if you're not familiar with SQLite, no worries. It's simply a relational database in which all of the data is stored in a plain single. They call it, sometimes they call it flat file database. It's called, all the data is stored in a flat file, single file database. Right. I also have a few videos about SQLite and using them in your own projects if you want to check them out on my YouTube channel. Now, with the database being a single file, if we can persist this file, so a nice idea is that can we persist this file? Because if we can, then we persist that file on the host, meaning on our Linux machine, which is on my machine, and then we can make it available to the next container. So we can set up as many containers as we want, but each container will look for the host machine. This is the host, and it's going to find that this todo.db, and it's going to use that. All right. So then each container is able to pick up where the last one left off, and each time you make changes to that, it's going to stream it back to the todo.db. So that's kind of the mental model I want you to have. So kind of imagine that there is this todo.db in here, and each container would basically, like, instead of storing todo.db in here, in its own container, it's going to look for the one on the host machine, and it's going to be the one, if you make changes to it, it's going to make changes as well to the host machine. All right. So any changes to this DB, when you destroy the container, it's going to be there on the host machine because you destroy the container, you didn't destroy the host machine, then the future containers could come in there and use that. All right, and it could pick up where the last container left off. So how do we do this? How do we create this nice special place to put our DB? So this is where we use volumes. All right, so we have to create a volume, and then we have to attach this volume. And usually the word attach is not very formal. More often you'll hear it called mounting. You mount that volume. Okay, so mount, M-O-U-N-T. So you hear people call it mounting the volume, and this is kind of creating a volume and then attach that to the directory that the data is stored in. Then all the future containers, when they write to the todo.db file, it will be persisted to this host in the volume that we mounted. Okay, so we're going to use a name volume for that. Now, how do we do this? How do we do all of that we just described? So let's clear all the screen now, and let's, first of all, how do we create a volume? Now, to create a volume, all you need to do is to say docker volume, and you could say create. So in this case, I'm going to say gtddb, I guess, get things done, and then put the -db to sort of remind myself that it's the database here, because you can use volume to do all kind of things. I want to just remind myself there, be a bit more clear and a bit more explicit. So docker volume create gtd-db. If I go ahead and do that and run that, it's now created a volume. So that's it. That's as simple as it is. Docker is not actually very complicated once you learn the most basic commands there is. And then now what we can do is we can say Docker, and we can say volume, and we can do a list, and it will show you all of that. And among those things, we will see that there is a gtd-db. So these are all the different volumes that I just created. So let's go ahead and make sure that our container is still running or not. It is still running. So if I refresh that, it is still running as well. Okay, that's cool. Now I want to actually stop this container. So clicking back to this, and I'm gonna just say Docker, and you could do a stop and then you can do a remove. You could do a stop and then do remove, but I'm gonna just save myself some time. I'm gonna say remove force 70b0, or you could put sweet clock, right? Sweet clock is the name of this container. So let me run that. Okay, now that that is gone, if I do a docker ps, I should confirm that there is no container running. That's cool. Now the reason I need to stop that is because the old container wasn't using the persistent volume, right? It's running without using the persistent volume. So now I want to start the gtd app container now again, but this time, so instead of doing docker run, let me show you. Normally we do this, right? We say dp 3000, and then we just have to say the name of the image. The name of the image, how do you find out the name of the image? You say docker images, and you find a list of that. This is the name, gtd. So what we need to do is to just say docker run, and put in the name of the image, and then we say map the port. But now instead of just mapping the port, we also want to actually say take that and then use the volume. Now if you say -p stands for port, what do you think volume what do you think the abbreviation for volume would be? If P goes to port, if D stands for detach, what about volume? Volume would just be V. So you add the V flag to say I want to specify a volume mount, and the way you do that is remember how we created the Docker volume earlier? So let's go ahead. If we forgot about all of that, we just say volume ls. We see that it's called gtd.-db. So let's go and say docker run, and here I want to say -v, and then I want to say take that and then map to gtd-db, map it to a destination. Now where is that destination? Right up here, it gives you the answer right here. It says this is the location. So you're saying that in the container itself, whenever you look for etc todos.todo.db, etc/todo/todo.db, actually look at this special location here, and the name of that location is called gtd-db. Now this is actually persisted on your machine, but for now I'm not going to go into where exactly on the machine. I'm going to do that in 3 minutes. In 3 minutes, you're going to see where to find this on the physical space of that. But for now, it's good enough to know it's somewhere on your host machine, which is if you're using MacBook Pro, Mac, Linux, Windows, it is somewhere on there. And we're going to see the physical location for that in a second. But for now, it's saying that every time this location is asked for, look for that volume. All right. So I'm going to have to copy that as well. I'm going to say /etc/todos. All right. So this is going to go into etc todos, and it's going to find that. So let's go ahead and run our container. We're going to just say enter, and it's going to run as usual. It's going to now give you an ID of 1F C8. So let's run this. Okay, let's add a few items. I'm going to say read books in the gym, and read gym in the books, gym books in the read. Just add a few items, doesn't matter what those items are, and just maybe check this off. All right. So if you go ahead and follow up to this point, now if I ask you the question again, if I close this container and I will destroy this container and I start a new container from the same image, what do you think is going to happen? Would I still have all these different things persisted, or would I not? If you have a second to think about that, but I'm going to now destroy that. So I'm going to say docker, and I'm going to say remove -force, and I'm going to say 1fc8, and that's going to destroy this. So if I refresh this page, refresh this page. All right, so nothing is here. Okay, restart the process. Again, restart the same process. And notice that the key here is that I'm still doing the volume flag -v, and I'm gonna still use the one that special location here called gtd-db. All right, so let me go ahead and run it. Okay, now moment of truth. Let's find out if we actually see it. Just run that, and what do you have? You see that the same, all of your gettings done, all of your tasks are still in there. So the states are still being stored. You can still see that some of our items are checked. The items that are deleted are still in there. If we delete this and then we destroy this container again and we create a new container, then it still makes no difference. You would still see all of this, right? So you could destroy as much container as you want, but your data is mounted into a special volume, and this volume sits on your host machine. So as long as your host machine is not destroyed, as long as your MacBook Pro is not destroyed, your Linux is not destroyed, it will forever be there, and your container can interact with it. And every time you make changes to your container DB, it will actually make changes to your host volume as well. Okay, so now a lot of the question that comes at this stage is, where is Docker actually storing that data when I use a name volume like that? So remember, we didn't actually have to find where it is, right? We never really have to specify location or anything. We just specify it by name, and the name is just gdd -db. So what we did was we said docker volume, and then we say create, and we just give it a name. And this is why it's called a named volume, a name, named named volume. And every time we do that, we just have to refer to it by name. We didn't have to actually care about where on the host machine is this location actually at. But if you want to know where it is, you could do an inspect, and you just have to pass in a name. So I can say gdd-db, and then it's going to give you some information on here. And the interesting part of all of this is the mount point, right? So it told you when is it created, whether it's a driver, whether it's local or not, because later on you could use something like bridges and stuff. We're going to go into those things a little bit more advanced later, but right now it tells you that when is it first created. And the mount point is what is interesting. It's telling you the actual location on your disk. All right, so if you're using a Linux machine or a PC or Mac, this is the location where your data is stored. Now note that on most machines, if you want to actually inspect this, you need to use root access. So you can't just go list like that unless you didn't really set up proper admin privileges. But if you do have those, you will need to do a sudo, you need to do an ls, and then you need to say var lib docker volumes, and then you can also specify this gdd-db. I'm actually probably just gonna run that and just show it to you first, but I'm not gonna go too deep. I'm not gonna dive any deeper into that. So if I just do a list, and it's gonna show me what I have. I'll put a -a as well to show me all the files, including hidden files. And password is wrong, so let's try that again. There you go. So I have a few folders in here. I have the superset Redis, superset home, because I was building some stuff with it as well. And then there's a few more directory in there. So those are there. So let's summarize that a little bit, because we've gone through a lot today, right? So the benefits of using volumes. In Docker, volume storage is not coupled to the life cycle of the container. So remember how we said that the containers are ephemeral, which means that every time you destroy it, all the data that goes, that all the changes they make to it, all the data, all the state updates, all of that is gone. So if you want to decouple that from the life cycle of the container, if you want to have a persistent storage, then you want the data to exist outside of it. And the way you use Docker volume is to just have your data exist outside of it in a special location, which we spoke about earlier. And that has many benefits. For one, you can actually kill your container now, maybe for some reason, if you're deploying that onto a Heroku service, or if you're using some sort of serverless paradigm, you can have the container killed, restarted as many times as you want, and you still have your data persisted because it's now independent of the lifecycle. Now, it's also easy to reuse storage in multiple containers. For example, one container could handle the writing. It could write to the DB, while let's say these two other containers, instead of writing, they actually have read access. So you could have these two containers doing read, and this could write. And because all of this, they interact with this special location that exists on your host instead of within your container's lifecycle, you could do that. So there's a lot of benefits to that. And since volumes are not tied to any container, you can also easily attach them to multiple running containers at the same time. You could have multiple containers being sort of mounted to this volume itself, this name volume itself. And you will also find that volumes don't increase the size of the Docker container using them. And that makes sense, because if you truly understand this paradigm, all of that actually happen on a host. So it doesn't actually increase the size of this Docker container, or this Docker container, or this Docker container, even though they're performing the read and write. Just to maybe put everything a bit clearer, we can also, let's see if we have the Docker PS. Okay, it's still running, so we can say Docker exec execute. We will execute in iterative mode, I guess, and we'll say fc24. That's the container ID that's running, and we could say list. So we said execute what? You want to execute list, and I want to list the etc/todos. So I'm gonna execute this path, the etc todos, and let me just run off that, and you will, sure enough, you see todo.db. And this is, if you want to interact with it in any way, any form, you want to maybe explore the DB if you have some sort of CLI tool that allows you to explore that with SQLite, or you could just go ahead and use SQLite to sort of explore the data. So you could install the SQLite CLI tool, and you could just explore that. You could also do that. But for me, I'm not. This is good enough. It actually explained all of that I want to explain with regards to volume. So I'm actually quite satisfied with where it is, and I'm not gonna go any deeper in that. So the last section that I'm gonna cover in this video is called the bind mounts. Okay. So in the earlier section, up to this point, we talk about name volumes, right? So every time we talk about volumes, one very common question is how does that differ to bind mounts, right? What are the difference between name volume and bind mounts, right? So name volumes are great if you simply want to store data. We don't want to worry about where the data is stored, because like I said, everything is managed by Docker, and it will tell you where it is if you ask. So if you say docker inspect and volume inspect, not inspect, but volume inspect, if you ask where it is, it will tell you where it's mounted. But generally though, you don't have to worry about that. It's not a thing you need to worry. It's just all of it is going to be managed by Docker. But with bind mounts, these are things are a little bit different. With bind mounts, we control the exact mount point on the host. We're gonna tell, okay, so this is up to this point, right? We're using the name volume. But now that we go into bind mounts, with bind mounts, we control the exact mount point on the host. We want to tell Docker exactly where it is. So we can use this to persist data, but it's also often used to provide some additional info into the container. One very common use case of using bind mount is when you make changes. So I'm gonna quit off this now. I think it's a little bit long, so I'm gonna clear the screen now. And actually, let's just open that up. Sorry, because we still need to sort of make changes to this anyway, right? So one very common use case of using the bind mount is when you work on an application, you use the bind mount to mount your source code, so all of the source code in here, onto the container, so that it can see code changes and respond, and then you can see the changes right away. So you don't have to rebuild the whole container, you don't have to stop and pause and run, you don't have to do any of that. So what it's going to do is that it's going to say that take this container, right, and use a bind mount to mount your source code. Your source code is written on your host machine, which is on my current machine is on my Linux, but you could be using a MacBook, you could be using a PC, whatever, right? And so all the changes in there, you mount it to the container, so you're keeping things in sync. All right, and for that you could use you will have to use one or two more applications. So I'm going to look at my package.json again, and so I have nodemon in here. Nodemon, I think it stands for node monitor. So it's a great tool to just watch for file changes and then restart the application. So because I'm using nodemon in here, and I actually coded that into the app, so every time I make changes, the app itself is going to be restarted to reflect those new changes. All right. If you're using something else, if you're using Python or something, there is always, I'm sure there are a lot of equivalent tools in all these other languages. So let's get back down in here. I'm going to clear the screen now, do a docker ps to make sure they're still okay. So let's go ahead and just remove by force. We say FC24. Just remove that completely. If you check that again, and the more you code up this stuff, the more muscle memory you generate, and then this stuff are not so difficult. The commands are quite simple. It's mostly the mental model that people struggle with, not the command, not the syntax. All right. Okay, to use the bind mount, the syntax, believe it or not, is actually very similar. So we will say docker run, and we still put all of this, but now that the command is getting a little bit longer, I want to add a dash here, a backslash here. And so I'm gonna just say expose whatever is 3000 from the container onto my host, and then what else? I want to also say the -v. But before we do -v, I also want to use the -w. So the -w itself sets the working directory. So I want to set the working directory to basically sets where the commands are going to be run from. That's not very different from what you see when we do the Dockerfile, right? So we go to Dockerfile and source. Right, so we have the working directory here. We set it to app. So not very different from that. We're actually going to do about the same thing here. So we are going to go ahead and we're going to say take that and then put that to app. So everything that happens in this command is going to be in a way you kind of cd into it. It's not really a cd, but you kind of think of it like you cd into app directory, and then from there on the rest of the command should just use this as that point. And it's more common that way. You don't actually try to, I mean you can, but it's just more conventional to put things into a sort of an app directory instead of, or source directory, something like app or source, instead of putting everything into that root directory. All right. And then what do we do next is we want to say mount the volume as well. This is very similar to what we say, what we have up there. Now earlier we used a name volume, so we have something like get things done db. We have something like that, right? And then we say take that and then map to wherever that is, right? Whatever app or whatever, like the right. So we have the etc to do the db. So earlier we could do something like take this and then mount the volume, but now we're not actually trying to mount the volume, because what we want to do is to mount the entire source code, the whole app directory, this whole directory. We want to mount that onto the whole directory of here as well. So we want to mount into this app directory itself, right? Not just looking at mounting the db. So earlier we want to look at earlier, right, we had the db, and we want to say that try to basically create a volume, and then all the db should work with this external this db that has this externality that is isolated from the rest of the container's lifecycle. But now we not want to do that. We actually want to say that every time in our local machine, every time we make changes in any of this code in the app directory, you want to stream that, and you want to actually have that changes being reflected in the container as well. So instead of actually doing that in db, what we're going to do is we're going to say -v, and we're going to say so we can use a nice little trick here. We could say something like take the $, and then we could say print working directory. So that is our current directory, and then we map that to app. Okay, so this has the effect of taking whatever it is that is happening in the current, in a host machine, there is the app directory. Whatever is happening in the app directory, map that to the app directory. This is the Dockerfile node modules package.json spec source yarn. So this is the same as what we have here, right? So we're gonna say this. So now what this is gonna do is it's gonna try and take, if any changes are made to any of this, it's gonna take all of this, right? Any changes that are made to this, it's gonna sync that with what's happening in the container, right? I'm trying to using these two pans to sort of like give you the mental model, like this is what's happening in the container, but really it's both of these are on my host machine. But just imagine this is on my container. I'm saying that anytime any changes here happens, you want to stream that. And same thing here, any changes that are made on the container, you also want to stream that back to my host machine, right? So I'm gonna go ahead. Is there anything else we want to do? We want to also say that when you run this, instead of running just the app and passing in the image name itself, I want to show you something else up here. So if we look at the package.json, so I'm going to go into my package.json and show you what I have there. I have nodemon, right? I have nodemon. And when there is also this script that says def. So what I want to do actually is I want to actually run this def. So I don't want it to, I want to say run def, because that's where it would kickstart my nodemon. And where is nodemon? Nodemon is way all the way at the bottom here, and nodemon is going to monitor changes and it's going to update the index.js, right? So this whole thing is a little bit more complex if you have never written any kind of code in JavaScript or any kind of like front-end engineering work, you've never done that before. So if you can't fully grasp what's the point of a nodemon or package.json, then that's secondary. I think the primary idea is how do we use this same paradigm here, and so if you don't understand nodemon, I don't think it's really the main idea, the sort of the main objective of this lesson anyway, right? So let's go back in here. So what I want to do is I want to kickstart this script when I run this image, right? So when I said run this image, or rather start this container, then go ahead and kickstart this process. And you know that everything in the scripts, you could do something like yarn run. So you could say yarn run prettify, yarn run test, yarn run def. So we might as well do that. So let's go ahead. Forgot to complete that. So we said run node 12 alpine. This is, a lot of these are the same as the Dockerfile. So if you look at my Dockerfile, let me open that up. You see that there's the node alpine. And what do we have after that? We have take this, and then we said run the apk add, right? So we want to say use the shell to go ahead and run the apk add. So let's go back into the second terminal, this one, and I'm gonna say run this, get in here, and then use shell and shell put a command in there and basically says exactly the same what you see up there at no cache, and I want to say Python 2, I want to say G++ make. Okay, and then if this is successful, then you say an end. So if this is successful, go ahead and then do the second thing, which is to do a yarn install. And then if that is successful, then go ahead and do the third thing, which is to do yarn run def. And yarn run def comes from the earlier one, which is the package.json. So if you go into this one, you see that the yarn run def basically executes this line, right? The def. So if I get back in here, and we're almost done. So we have docker run dp 3000 stringmate, set the working directory, mount the volume, and note alpine, and then we use the shell to execute everything we see in Dockerfile. Of course, we want to close the quotation. Let's run that. If you already have node 12 alpine locally, it's gonna just use the one locally, just like how I explained. But if you don't have that, then it's gonna go ahead and download that, and you see it's actually pretty fast. So all of them already exist, and it gave you this 1F1523. So if you want to, you could go ahead and say docker logs, and then you could follow 1523, and you will see that it's gonna go ahead and do all of this process where it says installing. These are basically doing all of the stuff up there where you're trying to ask it to install. Where is it? Python 3. Whoops, it's actually Python 3. We actually get it wrong there. So I doubt it would even work because we let's not actually even wait, because I know it's not going to be compatible, so I might as well change it right now. Okay, because port 3000 is already bound. Okay, so let's remove that, and I'm going to say remove 1523. Okay, done. Let's go and do this, run that. Okay, now we have that F681. Okay, so if we do a follow logs that, whoops, F68A, you're gonna see that it's gonna go ahead and just do that alpine and installing all of this. Now it's correct. And while it's trying to install all of this, let's talk a little bit about the commands as well. So again, dp 3000, that's the same as what we've been explaining. We run in detached mode, and then we try to create a port mapping to map the containers 3000, port 3000 to our host 3000. And then the -w sets the working directory or the current directory that the command will run from in the container. -v, that's basically the volume. V stands for volume. It binds, it basically bounds or bind or mount the current directory from this host in the container into the app directory in the in there, right? So this is the host. This is wherever the host is. So in this case, it's actually here, home Samuel and an app. And it says every time there's any changes happening in home Samuel app, you want to take the changes and you want to reflect that into the app. So that's basically the working directory. All right. So basically all of the the 3 folders and the 3 files in here. And then the next thing here is the node 12 alpine. This is the image that you want to use. This is the base image from the Dockerfile itself. If you click on Dockerfile, you will see that there is the from node 12 alpine. This is where it came from. And then next you will have the shell sh-c. So typically you use bash or g shell nowadays, right? Or fish. So bash or g shell or fish. But Alpine being a very lightweight Unix Linux distribution, it doesn't have bash. So we use sh, the shell, instead, and we said use the shell to execute the following command. And when you see this end, what this is to basically say that if the command here is successful, go ahead and execute this. If this command is successful, go ahead and execute that. So it's kind of like a short code here. It's kind of like a circuit, kind of like saying that if this works, then goes to this one. If this works, then goes to this one. So the first one here came from this line, apk app, and then it says if that is successful, then you want to say yarn install. Then if that is successful, you want to say yarn run def. And where is yarn run def from? It's from the package.json. That is going to kickstart the node mon. All right, so that's kind of what it's doing step by step. Now we're just gonna have to wait for the installation to complete. And we're done. So you see that nodemon source index.js That's the outcome. That's kind of the final instruction we gave it, right? Let's take a look. Shell apk and then yarn run dev. This is yarn run dev. It says node mon source index.js, and it's saying that it's watching for any changes, actually any path, and then watching for extension JSON. So anytime we make any changes to any of the JavaScript files, JS file, then it's gonna go ahead and restart the node service, and we should see the changes being reflected. Okay. So let's go ahead and test out all of this and see whether it's working as expected. So let's go into what do we want to change? Let's maybe change a couple of things in the source folder. So let's go into source. Let's take a look at static JS app.js. Let's do that maybe. And there's so there's nothing in JTD at one above. All right, that's cool. But let's also add something else. Let's also change a couple of things. Let's say 109 G. Instead of adding an add item, we could go ahead and just say add, okay, or add task rather. So I want to just go ahead and just replace word, change word, and I want to say add task. I'll put an exclamation mark like that, right? Just to make sure that we can actually tell there's a difference. And if I get back in here, you see that at task, now the changes is being reflected. And if I go to my terminal and I add a plus sign and I write the file and I refresh this, you see that that's also being changed. That's also being reflected, right? So all you need to do is to just refresh the page, and you don't have to rebuild this anymore. You don't have to get the container down and then get an image to rebuild the image and then build the container again. You don't have to do any of that. So all the changes are reflected in the browser almost instantaneously. All right. So if you get any delay at all, it's maybe because of your node server. So it only takes a few seconds for the node server to restart. And if you get any delay at all right. So if you see an error or anything, just try to refresh that after a few seconds, and that should be fine. So you could make changes now. Let's find a nothing in GTD line. Let's say nothing. It's actually here, nothing in GTD. So if you want to change this, hop over here. Instead of doing that, right, I'm gonna say add a task. Right, just say add a task. And if we write that down, so put a W save, and if you refresh the page, you see nothing in GTD, add a task. So you could make any changes you like to make, as long as when you're done, you can just stop the container, you can build your new image, and then you could publish them or something. So I'm gonna go back in here now. I think we covered almost everything we want to cover, which is quite a lot. But Control C to stop that out. If you do a Docker PS, you should see that there's a condescending Maninsky. So we could do a Docker and remove .false and then put a condescending. And you just have to press tab. So you don't even have to type the name out. Just say CO and then tab. It will just complete that for you. And it's going to remove that. That's kind of a tour of what the bind mounts is and what the volumes is. And the context, actually, let me show you the syntax again. Just show you that the syntax is not actually very different. This is kind of the magic here, right? -v, and then this is the working directory and then app. So what it does is that every time you make changes to anything at all in the current working directory, because you're mounting the working directory into your to this app subdirectory. So any changes at all, whether it's in your app.js, whether it's babel.mean.js, whether it's the react.bootstrap, whether it's react.production.mean.js, any of that at all, right? Those changes are going to be streamed to the /app directory. So as a recap, using bind mounts, very, very common for local development setup. So you don't want to actually have to do some coding and then do some development and then have to remember to destroy a container and then rebuild an image and then rebuild a container and then stop that again. And every time you make changes, you have to do that. That's a lot of work. So the advantage is that the dev machine, right, it doesn't need to have all of the build tools and environments installed. You can just use a single Docker run command, and then the dev environment is put and ready to go. And then you can make changes to it. And every time you make changes to it, you could basically use the volume, the bind mounts method to which you've seen here, to reflect those changes. So as we bring this lesson to a close, right, in the next lesson, we're going to look at Docker Compose. That's something more sophisticated. And we're going to look at Docker Compose, and that we'll see how Docker Compose will simplify our commands, which this gets a lot of flags. Like, look at that. It's quite a lot of things here, right? So how do we take that and put them into this format called Docker Compose using a YAML format, and we'll see how to maybe modify our current setup to use that new workflow. But at this point though, we can already persist our data. You could already try and go ahead and add a few more tasks, and right now it's not going to do anything because we just destroyed that. So if you refresh that, it's nothing. But you could already see that you can persist your data. You could respond rapidly to the changes from on your code base, and bring that into your container, and you have this kind of sort of a two-way binding between what happens in the container, whether you want to persist data, you want to sync your code, your file changes, any file changes onto your containers. You can do all of that already. And so that's it for kind of a very high-level, practical, hands-on example to Docker. And again, I said the best way to supplement this lesson is to actually go and watch, maybe read up some of the overview, take a look at what the Docker architecture is, why it's unique, why it's nice. I suspect that most of you have already done that. A lot of you have done that already. You already have a mental model of what it is. You just really want to look at how it works out from a code point of view, right? And so that's kind of what I try to bring in with this lesson. It's just really a very code-heavy, kind of a hands-on kind of demo. And so I hope you enjoy a lesson. I'll see you in some future videos. Goodbye.